Let's talk about polynomial functions. And in the course of talking about polynomial functions, we'll be going through power functions also. A polynomial function of degree n is defined as y equals to f of x equals a n x to the power n plus a n minus 1 x to the power n minus 1 plus up to a1 x to the power 1 plus a0 x to the power 0, where this n is non-negative positive number, is non-negative integer. All these an minus 1, a1, a0 are coefficients, okay, and we can say that then this is a polynomial function y equals to f of x equals to an x to the power n up to a1 x to the power 1 and a0. And also we must note down that this an must not be 0. Okay, an is called the leading coefficient, and degree of this polynomial is the highest power of x, which is n. Power function only consists of the leading term of the polynomial function. Okay, and let's talk about the general nature of curves of power function. Okay, so we try to refer that to as a table. So let us draw a table. Let's divide the table in this way. First, talk about the degree of the power function. N is even, n is odd, and the leading coefficient a is greater than 0, a is less than 0. So whenever a is greater than 0, we will have a curve something just like this. Okay? The curve will open upwards, and you can see that it goes on infinity. Whenever we go towards either left, that means towards negative infinity, or towards positive infinity, the curve or the value of the function goes towards infinity. So is x goes to plus or minus infinity, f of x, okay, y equals to f of x goes to infinity. Whenever we have a is less than 0, then our curve, it will open downwards. As x goes to positive or negative infinity, the entire curve or the value of the function goes towards negative infinity. Let's talk about when n is odd. When n is odd, we will get a function. The curve would be something just like this. Okay, whenever x goes to negative infinity, f of x goes to negative infinity, and whenever x goes to positive infinity, f of x also goes towards positive infinity. So that happens whenever we have n is odd, the power function, its power is odd, and a is greater than 0. And whenever we have a power function whose leading coefficient is negative, then we'll get a function something just like this. Okay, then we want to realize that as x goes towards negative infinity, f of x goes towards positive infinity, it goes upwards, and whenever x goes to positive infinity, f of x goes towards negative infinity. So that's the end behavior of power functions, or this can be even generalized in terms of polynomial function also. Okay, so this is also true for the polynomial function.